Welcome to our review on waves and their properties. So the first thing we actually need to know here is what is a wave? So whenever we're talking about a wave, quite simply, we're talking about an oscillation that's going to transfer energy. Now we've got two types of wave that we need to concern ourselves with. First one are the mechanical waves. So these would be sound and water, for example. And mechanical waves need a medium to travel through. The second type of wave are the electromagnetic waves, and these do not need a medium to travel. So make sure you know the difference between the mechanical and the electromagnetic waves. So when we're considering waves, we need to know that they can either be a transverse wave or a longitudinal wave. If we consider the transverse wave first of all, then what we see there is that the vibrations are going to be at right angles to the direction that the wave is travelling. So we can actually see that in the bottom right there. So you can see the little diagram, the wave is travelling towards the right of the screen, and then the vibrations are at right angles to that, so you get that pattern of going up and down, the peaks and the troughs. The second type of wave are the longitudinal waves. And these ones, their vibrations are in the same direction that the wave is travelling in. And we can see the diagram of that in the bottom left. Now, what we actually see there is you get these areas of compressions where the particles are much closer together. And then you get the rarefactions where they're more spaced out. So make sure you know the difference between a transverse wave and a longitudinal wave. And you can also label those diagrams. Another key thing we need to remember are some of the key wave properties. So what we've got here is a little table with 4 of those key wave properties that we need to know. So the first one is the amplitude, and if we're looking at that, it's the distance from the middle to the top or bottom of the wave, so to the peak or the trough. It's given the symbol A, and the unit is going to depend on the wave, but usually we tend to see this measured in meters. The wavelength is our second property, and this is the distance from one point on a wave to the same point on the next. So it might be from the top of that peak to the top of the next peak. And you can see the symbol for it there in the third column along. And again, this will be measured in meters. Third property we need to know, the frequency. This tells us the number of waves or oscillations that occur per second. So its symbol is a capital F and is measured in the units hertz, which have the symbol of Hz. The last one, the time period, this is the time for one wave to pass a given point. And this is going to be measured in seconds because we're talking about time. Now you could see 2 different ways that we can represent waves. First one is as something called a time trace, and the second one is called a snapshot. So both of these are graphs that allow you to measure amplitude, which is going from that middle line to the top of the crest or the very bottom of the trough. So you can measure amplitude from either a time trace or a snapshot. So if we look at the time trace first of all, I've given you an example on the right hand side there. Now, as with most graphs, the first thing we need to do is have a look at the labels on the axes. So we can see displacement on our y-axis in meters, and on our x-axis, in this case, because we're looking at a time trace, it's the time in seconds. So as I just said, we can measure the amplitude on a time trace, which is taking us from that central line up to the top of the peak there, as you can see. And what we actually get on our time trace is a graph that's going to show us how displacement varies with time at a particular position. So what we can actually do then is we can measure the time period, because that's going from any point on one wave to the exact same point on the next. And if they were to ask you to calculate the time period, all you'd need to do is 1 divided by the frequency. If we have a look at our second graph, the snapshot graph, what you'll notice is the x-axis label is different. So as I've said, you've got to look at the x-axis label in order to identify, is it a snapshot or is it a time trace? So because we've got distance, it's a snapshot. And the snapshot will show us how displacement varies with distance at a particular time. Now, what we can do on our snapshot then is we can actually measure the wavelength. It's going to be from any point on one wave to the exact same point on the next. And again, we can measure the amplitude, as you can see shown on the graph there, because we're going from that central line to either the top of the peak or the bottom of the trough. The last thing we need to know about is how we can actually model these waves. So hopefully in class you've actually seen this demonstration using a ripple tank. So because we can't see waves, we need to use something that we can see. So we can use water waves for this, which is what the ripple tank actually does. So I've given you a little diagram there just in case you've not seen one. It's basically a plastic tray with water in there, and then you've got a little paddle or a little sort of ball on a stick, and it will vibrate at a fixed point. And as it bounces up and down in the water, it creates little waves, which you can then see underneath, as you can see there by shining a light through it. So this is going to allow us to carry out the models on the different waves. We can see how they then behave. So when you put different objects in, what's the impact on those waves? So we can see reflection, etc. So just bear in mind that we can use the ripple tank in order to carry out this modelling. Hopefully at the end of this video you can now describe wave motion in terms of its amplitude, wavelength, frequency and period. You can define wavelength and frequency. You can describe the differences between our longitudinal and our transverse waves. You can describe how we use a ripple tank in order to model this. And you can also talk about the fact that the wave is travelling, not the water that travels.